Evaluating a multiple choice question exam reliability in both Excel and SPSS using Kuder Richardson Formula 21, abbreviated as KR21. Kuder Richardson Formula 21 is different from the Kuder Richardson Formula 20. However, the formula calculates the reliability of binary tests. Binary means that it's dichotomous, only have two options, such as multiple choice questions in which the answer can be either correct or incorrect. Correct will be given a value of 1, an incorrect answer will be given a value of 0. So the KR21 measures the consistency of exam scores. The formula assesses the inter-item consistency, and the Kuder Richardson Formula 21 is used instead of the KR20 when the questions in a test all have approximately the same difficulty, i.e. the mean score of each question is approximately equal to the mean score of all the questions. The KR21 values range from 0 to 1. 0 mean unreliable exam or test. A value of 1 means that it's extremely or it is an excellent reliability of a test or an exam. Kuder Richardson Formula 21 is described here equal to K divided by K minus 1 multiplied by 1 minus the division of mean multiplied by the K minus the mean divided by the K multiplied by the variance. The K here stands for the total number of questions. The variance is the variance of the total score, and the mean is for the mean of the population. The following table shows the KR21 value and the reliability level. If an exam has a value of KR21 of 0.9 or greater, then the test will have an excellent reliability. A KR21 value between 0.8 and 0.89 is considered as a good reliability. A test that will have an acceptable reliability when the value for KR21 is between 0.7 and 0.79, and that a questionable reliability of a test when the value ranges between 0.6 and 0.69. A test will have poor reliability when the value is between 0.5 and 0.59, and a multiple choice question, exam or test will have an unacceptable reliability or is unreliable when the value for the KR21 is less than 0.5. Reliability test for multiple choice question exam in both Excel and SPSS using the Kuder Richardson Formula 21, abbreviated as KR21. Reliability test for multiple choice question exam in Excel using Kuder Richardson Formula 21, abbreviated as KR21. Reliability test measures the internal consistency of items or questions, i.e. the score consistency. If an exam or a test that consists of multiple choice question is repeated with the same student at different date, the student scores in both dates will be similar, i.e. the scores will be consistent and the exam will be reliable. So one of the methods to test reliability is to use the KR21 formula. However, this formula only used in certain conditions instead of the formula KR20. So there are two formula, KR20 and KR21. The KR21 is used when the questions have similar difficulties, i.e. the question mean score is equal to the mean score for the total questions. The KR21 value ranges from 0 to 1. 0 indicates a non-reliable or unreliable test, and 1 means that the test is extremely reliable. The formula for the KR21 equal to K divided by K minus 1 multiplied by, in between bracket, 1 minus the product of mean multiplied by K minus the mean divided by K multiplied by the variance. K stands for the total number of questions. Mean is the mean for the total score, and variance is the variance for the total score. Here in Excel, I have a data for an exam result for 10 students answered 15 multiple choice questions, question number 1 to question number 15, and they scored the result, and the result was reported as either 0 or 1. 0 means wrong answer, 1 means correct answer. So this data here is a dichotomous data or binary data. There's only two options, 0 or 1, right or wrong. And to evaluate and assess the reliability of this exam that has the 15 multiple choice questions, I will use the KR21 formula given here in this corner. And to do that, I had taken part of this formula and placed it here in this column. And the first step for doing the analysis for the test for the reliability is to calculate the total score achieved by each individual student. And the way to do that is to add all the scores achieved by every student together. So in this column here as Q, we're going to call it total score. And then in the cell below, I'm going to add up all the value or the scores achieved by each student. And the way to do that is to click on the symbol for sum and then select the range of the data or input data from Q1 to Q15. Hit the enter key and the value of 14 is generated, which is equal to the correct answer achieved by the first student. To calculate the total score for the list of the student, hold the cell, drag, and then the software will auto calculate and auto fill the value for each individual student. So now I have obtained the total score. The next step is to calculate the mean. To calculate the mean is to select the cell here and then scroll down to the average and then select the range of the data from student of total score for the first student up to the student number 10 and hit the enter key. A value of 6.2 represent the mean for the total score. The next step is to calculate the variance for the total score. Again, select the cell, insert equal sign, and then type VAR, which stands for variance, and choose the first option, double click on it, and then select the range of the input data from student number 1 to student number 10 with their total score, and then close the bracket and then hit the enter key. A value of 22.36 is generated. Now to calculate the KR value, I'm going to copy and paste this value to the corresponding mean and variance. So if we select the mean here, copy and then place it with and paste it here with this option, and then select the variance, copy and place it here into the variance with these options. Now we have the mean and the variance already calculated. The K stands for the total number of questions. In this case, there are 15 questions. Next step is to calculate the upper part in this equation. And the way to do that is to insert the equal sign and then select the mean and then multiply that by and then open a bracket, and inside the bracket we're going to place the K here is 15, subtraction, minus sign, and then the mean again, select this value again, and if we hit the enter key, a value has been generated. To calculate the lower part of this equation here, again insert the equal sign as the K is 15 here, and then multiply that by inserting this multiplication sign by the variance that we already calculated, and then hit the enter. A value is generated. Now the final step is to assemble all these components, all this part for this formula to calculate and to generate the KR21 value. So in this cell, insert equal sign and then open a bracket, then add the multiplication sign and then another bracket. In the first bracket, going to add the K divided by K minus 1, which is equal to 15 divided by 14. In the second bracket, I'm going to add number 1, then minus the upper part divided by the lower part. And the upper part is this value here. And then we are going to add the division sign divided by the lower part, which is this value here, and then hit the enter key. A value for reliability has been generated and it is equal to 0.9. Looking at the table here for the KR21 value and corresponding reliability, the this test or this exam is extremely reliable. As shown from this table, any value for the reliability of 0.9 and greater will have an excellent reliability. An exam will have a good reliability when the value is between 0.8 and 0.89. An acceptable test with acceptable reliability will have a value of 0.7 to 0.79. A questionable exam when its reliability has a value of 0.6 to 0.69. A value of KR21 ranges between 0.5 and 0.59 will have a poor reliability, and an exam or a test will be unacceptable or unreliable when the KR21 value is less than 0.5. So this is the way to evaluate and assess the reliability of an exam or a test that only contains multiple choice questions, by using the KR21 formula only in certain conditions when the questions have similar difficulties. Exam that consist of multiple choice questions reliability test in SPSS using Kuder Richardson Formula 21, KR21. Reliability test is one of the method to assess the internal consistency of item or questions and score consistency. If a same test that contain multiple choice questions repeated with the same student at different dates, the scores of the students in both dates will be similar, i.e. the scores will be consistent and the test will be reliable. The formula for the KR21 is used instead of the KR20 formula in certain condition when the questions have similar difficulties. The KR21 value ranges from 0 to 1. 0 means the test is unreliable. 1 means the test is extremely reliable. The formula for KR21 is given here below. It's equal to K divided by K minus 1 multiplied by 1 minus the mean, and then this mean is multiplied by K minus the mean divided by the K multiplied by the variance. K stands for the total number of questions. Mean stands for the mean of the total score. Variance is the variance for the total score. Here in data view in SPSS, I have a data taken from an exam that consists of 15 multiple choice questions labeled as Q1 to Q15, answered by 10 students. The score for each question was recorded as 0 for wrong answer and 1 for correct answer. So the data here I have is a dichotomous data or binary data. Dichotomous means that there are only two options, correct or incorrect, 0 or 1. And to assess and evaluate the exam and to determine the reliability of this test using these 15 multiple choice questions, I'm going to use the KR21 formula. In SPSS, there is no command or function to do that. I need to assemble and use the equation given previously and calculate each component and then work out the value for the KR21. The first step to calculate the reliability of the test using the formula is to calculate the total score achieved by individual student. And the way to do that is to add all the values, the correct answer achieved by each individual student. To do that, click on transform, select the compute variable, and in the compute variable a new window appear, and I'm going to generate a new target variable, call it total score. And then I'm going to use a numeric. In the numeric expression, I'm going to look for the sum command and place it here. And to look for it, click on the all in the function group, scroll to statistical, then select the sum in the below box, drag the sum into numeric expression. And to add up all the values or the scores achieved by each individual student, need to use the command and then followed by bracket and insert the variables one by one between this bracket, separated by comma. So for the first variable, I'm going to add that in between the brackets, select the first one and then add the second one, and then insert a comma, and the fourth, and the same, and the sixth. And every time I enter a variable, it has to be followed by a comma, and we do that until we insert again. I have to add a comma here between these two variables, otherwise the package will not execute the command. So, and then I'm going to add Q13, comma, Q14, comma, Q15. So the SPSS will generate a new variable for adding the values for achieved by scores, values and scores achieved by each individual student. If you're clicking OK, a new variable is generated called total score, and the total score is for each individual student is equal to addition of all the correct answer achieved by every individual student. The next step is to calculate the mean for the total score and the variance for the total score. And to do that, click on Analyze, scroll to Descriptive Statistics, then select Frequencies, and then scroll down to Total Score. Again, I just noticed here the total score, the measures for it, I need to visit the variable view and change the measures because this is a scale measure. I need to change that into scale. So back again here into Analyze, Descriptive, Frequency. I'm going to transfer the total score into the variable box, and then I'm going to select from the statistics icon the mean, as I need the mean for the total score and the variance for the total score, and then I click on Continue. And if I click on OK, an output will be generated in the first table, statistic tables or statistics table, total score here, a mean has been calculated and a variance. And I'm going to use this mean and variance and place them here in this equation to calculate the KR21 assisted by a calculator. So I'm going to select the mean first, double click on the table, and then select the value, copy, transfer that and paste that here in this formula. And I'm going to reduce the decimal point into 6.2, and then also place 6.2 in here in the upper part. For the variance, I'm going to again double click on it and then copy and then paste that in the lower part here, and I'm going just to use 2 decimal points. I'm going to put an multiplication symbol here and a multiplication symbol here. We already know that the K represent the total number of scores, the total number of questions, and the questions are 15 in this case. So K is 15 and K here is 15. So using the calculator, I'm going to calculate first the upper part, 6.2. I will start first calculating the 15 minus 6.2. 15 minus 6.2 equal to 8.8. Multiply that by 6.2 will give me a value of 54.56. Copy this, place it in the upper part of equation here. And for the lower part, again, we do the same. Multiply 15 by 24.84 is equal to 372.6. Select, copy, and then place it here at the lower part. And get rid of that number. The next step is to find the product of dividing these two figures. So 54.56 divided by 372.6. Hit the equal, and a value of 0.146 is generated. So I'm going to remove this part, replace it by 0.146. Again, using the calculator, reset this. 1 minus 0.146 will give me a value of 0.854. Then we need to multiply that by the K, divide that by K minus 1, and the K here is 15, so multiply that by 15, 15, and then divide that by 14, 14, and a value of 0.91 is generated. All will round it up to 0.92. So the value here will be equal to, we can add the equal sign to 0.92. So what does that mean? This value represent the KR21, the reliability, and that means the exam or the test with this multiple choice questions, 15 multiple choice questions, have a 92% reliability. This is an excellent reliability, and it is well known that any KR21 value of equal to 0.9 or greater will have an excellent reliability, and anything below 0.5 will be considered as unreliable or unacceptable test or an exam. So here now in SPSS we can calculate and assess the reliability of multiple choice question exam using the KR21 formula to determine whether the test is reliable or not.